Welcome to LNP Renewable System Integrator. We wish to raise our prayers for the people who lost their life in the train accident. So today we are going to discuss about the train collision avoidance system basics. Okay. So what are the things that we are going to discuss today in this session? What is train collision avoidance system? Okay. How this system's functionality looks, what are the operational functions of a train collision avoidance system, and what are the salient features of train collision avoidance system, and what are the operational modes in the Locos train collision avoidance system, and what are the subsystems of train collision avoidance system, and what are the train collision avoidance system key components. Okay, how station master's control interface panel, control cum interface panel looks like. Okay, how Locos train collision avoidance system schematics looks, and what are the communication systems of absolute block system and automatic block system looks like, how it works. Okay, how network management system connectivity diagram looks, and how a cabling scheme of a train collision avoidance system looks like, and what are the key related activities and how it looks, and what is anti-collision network, that is RAKSH KAVACH, and what is the track AD and its type, and what are the different types of prevention of collision, how ACD work implementation is planned, that is anti-collision devices work implementation is planned. So this is some of the example of a metro station, how it looks. So in our discussions we might be using so many abbreviations and short forms. So if you have any sort of doubts, okay, when referring to the video, kindly please refer to these abbreviations and its description clearly, so that you will get a clarity of the things that we are discussing in our discussions. Excuse me. Okay, so first and foremost thing, we need to know how a collision happens. Okay, why we need this system, this train collision avoidance system. So as you can see here, when there is a train, okay, which is crossing through it, because of some emergency situations, or if the train got stopped, or if it met with any sort of accidents, the train which is crossing through it should stop automatically when it detects any sort of train in that particular path. So that is the important purpose of this train collision avoidance system. If it is not available, it can create damage. So if it is present, it will stop automatically. So that is the basic purpose of this train collision avoidance system. And most importantly, in our discussions, it is what are the things which plays a very important role in a train collision avoidance system. So we can categorize it in two different ways. Okay, we have a station side, station building, and we have a train side. Okay, we have equipments inside the station, and also we have equipments inside the train, and also we refer to the support of GPS satellites and also the radio antennas. Okay, so with the help of these different type of signaling systems and the equipments which is present inside the Locos train as well as the station, we are going to enhance and maintain this anti-collision systems, especially the avoidance of train accidents. So what is this train collision avoidance system? So it is an indigenously developed automatic train protection system, okay, which is meant to provide protection to the trains against the signal passing at danger. If any trains which passes the signal, okay, which is at danger, if it is passing at a very excessive speed, and if it creates any sort of collision, in order to avoid it, in order to prevent it, we need the help of this train collision avoidance system. Okay, so and most importantly, it provides everyday update. Okay, the movement authority. Okay, so it means it will provide at what distance it is traveling, at what speed it is traveling, what is the location of the train. Okay, whether it is inside the danger range or it is exceeding the limit. So all these sort of information will get with the help of this train collision avoidance system. So as you can see here, so what are the features of this train collision avoidance system? First and foremost feature is that we need to prevent, the train which is passing the signal at danger, that is SPAD. Okay, SPAD here refers to signal passing at danger. Okay, first feature is that. Next, we need to prevent its important feature is to prevent the collision between the different logos. So it means consider this is a train track. Okay, if one logo is going through this way, okay, if the other logo is also coming, okay, they should not collide. Between some distance, both should stop. So we are preventing the collision between the locos which is equipped with the TCAS. So inside each and every loco also we will have a train collision avoidance systems. Okay, and most importantly, next important purpose is that we need to display the approaching signals with the aspect in cab. So it means we need to provide the signals then and there. It means something is happening, something is faulty, some emergency has been happened, so you should stop, you cannot cross, like that. We need to display the signals. Okay, next we need to prevent the overspeeding. So if say for example, if the train needs to travel at only this speed, that is a limited speed, if it is exceeding that limit, then immediately it is the duty of us to prevent this overspeed. Okay, and also and most importantly, okay, if a train is crossing at a very high speed, okay, we need to make an automatic whistle at the LC gate. Okay, LC gate here refers to where the locking, okay, where the we can limit the passing through of a train or through the persons in the concerned track path is with the help of the gates, either through manned or unmanned gates we need to prevent. So that automatic whistling also we need to provide, and SOS message we need to provide. What is this SOS message? So you will have a doubt, what is this SOS message? So SOS message is nothing but the save our souls. So it is a distress message. So it means the systems will provide the SOS messages. Okay, so it should be capable of creating such sort of image. Okay, save our soul. Okay, SOS refers to save our souls. Okay, and most importantly, it has a centralized real-time monitoring of a train collision avoidance system, train movements in with the help of the network management systems. Okay, and also most importantly, we have a secure communication between the loco train collision avoidance system and the stationary train collision avoidance system. So we have a very good secure communication between the loco train collision avoidance system and the stationary train collision avoidance system, and also we can able to compute the train length. Okay, so with the help of this system we can able to easily identify what is the biggest distance, okay, what is the starting point of the train, what is the ending point of the train, what is the length of that concerned train. All this information we can get with the help of this train collision avoidance system. And most importantly, we need to follow the safety standard SIL4, which is certified as per European nation standard, that is 50126, 50128, EN 50129, EN 50159. So all these standards, so based by taking these standards as a reference, this train collision avoidance system has been created in our country. Next, so what how its functionality, okay, functionality schematics looks like. As you can see, this is a train loco, okay, and this is the station train collision avoidance system which is already there. Okay, as you can see inside your train loco, okay, inside your loco you have a provision to see everything. What is the speed, what is the station, what is the target station, okay, what is the at what speed it is running, okay, what stations we cross through, all these details will be there. As you can see here, so we have a tower which is being present on the land area, okay, the path which the loco train will cross through. As you can see inside the loco we have a radio antenna, we have a GPS antenna. So both at the starting point as well as the ending point also we have a GPS antenna and also radio antenna, and inside this we have so many protection devices. Okay, those things we see in detail, okay, when we get into it. As you can see here, so it is a closed loop. So this antennas will send the signals to the radio antennas and also receive the signals from the to and fro signal transmission, and receiving is happening between the tower and the loco TCAS, and also from there from the tower the informations will be get exchanged with the station train collision avoidance system. And also as you can see here, if there occurs any sort of issues, and most importantly what is the signal, what is the track status, and most importantly say if we are receiving any sort of save our soul messages, so those things, and most importantly with the help of the network management system we are managing the entire train collision avoidance functionalities. Okay, so what are the operation functionalities of this train collision avoidance system? First and foremost thing is that we will get the information from the stationary train collision avoidance system unit from loco train collision avoidance unit. That is, what is the direction of the train movement, okay, and what is the exact location of the train, and what are is there any sort of emergency messages that we need to convey. So all these things will be the most important operation functions of the TCAS. And also we will receive the informations by the stationary train collision unit. From interlocking also we will receive what are the messages that we will receive. Most importantly, we will receive the approaching signals, and we also receive the berthing track circuits status. We also receive the point status. We will also receive the route locking status, and most importantly we will receive the status of the block instrument line closed condition, okay. And also we will receive the informations by Loco TCAS unit from the stationary TCAS unit. What are the information that we will receive? So we will receive the approaching signal on the route, okay, and we will also receive the distance from the train's position exactly with the using the absolute block system. We will get the signal distance, okay, and what is the signal identity, and most importantly next, what is the next signal aspect, okay, and in what territory it is, whether it is in the same stationary territory or it is in the some other territory, okay, and most importantly whether we are receiving the signal, whether the signal is on or not, and most importantly we will also know the movement authority, so the distance for which the train is authorized to travel. So movement authority is very much important. If the train is authorized to travel from this station to this station, then immediately after reaching this station it stop. If it is crossing through it, it means it is reaching the movement authority limit. Then we need to raise a signal to the concerned authority personnel. And most importantly, static speed profile is also very much important, and temporary speed restrictions also we can create with the help of this train collision avoidance system. So most importantly, how we are determining the direction of the train. Say for example, this is a train track, okay, we have trains here, okay, which is passing through it. As you can see here, in order to determine the movement of the direction of the determination, we need the help of this RFID tags which is being present on the tracks. Say for example, this is the starting point of the train, this is the end of the train. Consider this as a RFID tag, okay. This is also the RFID tag, okay, in this concerned track. So when the train is passing through it, if the starting point of the train is passing through it, so immediately, even though this is a tag, inside the train we have a RFID reader. So the duty of it reader is to read the tag. So once it read, so we will get the information that train is at that concerned location. It is reaching at particular position. All these things we will receive, and also when it is crossing through the another tag also, we will also came to a conclusion that so train has crossed through. If the ending point of the train is reading, okay, the RFID reader is reading the RFID tag which is present here, so we will can come to a conclusion that train has passed through that concerned junction or concerned location. So with the help of that we can able to determine the direction of the movement. And also we have three types of direction of movement. One for the train moving forward or reverse, second for the train which is moving up or down, and the other movement of direction such as nominal or reverse. So it means we have three different categories of directions. One is moving forward, and the second one is the moving reverse, and the third one is the up, and the fourth up and down, okay, and the other third most important thing is the either nominal or reverse. So this is how basically the movement of the trains happens basically, okay. And most importantly, so how we know the direction? Direction shall be derived when the loco train have been passed two RFID tags in absolute location, okay. So it means exactly if you cross through the two RFID tags, we can able to came to a conclusion that this is confirmed for sure it is passing through that concerned direction. And the absolute location, how we can determine the absolute location? Very simple. If it is in if it is incrementing, if the absolute location value is incrementing, we can came to a conclusion that it is working in a nominal direction. If the absolute location value is decrementing, so it will be treated as a reverse direction, okay. And most importantly, the direction of a movement of a train and a tin shall be used for determining whether two trains are approaching, one following the other or going away from each other. So those things also we can able to identify with the help of a direction of movement of a train. And also stationary train collision avoidance system shall use the direction of movement of loco to find the approaching signals of the loco train. So with the help of this the station's train collision avoidance unit, it will use the direction of movement of the loco train. Okay, and most importantly, okay, how we will know new train has formed. Say for example, consider a situation, there is a train, okay, which is in the loco shed, okay, service center, okay, which is at the electric. Consider there is a train which is in the electric loco shed service center, so it has been taken to the service. Now after finishing of the concerned service, so we are taking that electric loco back to the track for to start its duty. Okay, to start its duty, we are taking it back to the station track. It means when immediately, okay, when it is coming to the track, okay, when we switch on or when we restart the loco train collision avoidance unit, we came to know that the new train has been formed. We will come to know that new signal we are receiving. It means when it is powered off, we don't receive any sort of signals, we will just know some train is there, that's it. But when it is switched on, we came to a conclusion that some new train is on the track. So it means we will find out the new train formation when we switched off this loco train collision avoidance system. Okay, and also the unit has come out of either a non-leading or shunt mode or system failure or isolation mode. Okay, and also when driving cab or a desk is changed except when loco train collision is in the shunt mode. Okay, then how we are determining the train length assignment? So as you can see here, every stationary train collision avoidance system shall monitor and the status of the track section identified by the measurement of the train length. Okay, it is only applicable to station, okay, train collision avoidance system, and also based on the time of occupation and clear status of these train sections communicated by the station's stationary train control unit, loco train control unit shall calculate its train length. So it means based on the most importantly, based on the status which is being monitored by the station train collision avoidance unit, the loco, okay, the loco train collision avoidance system will calculate the train length. Okay, say for example, consider we have two track circuits, say AT and BT. They are in sequence with the traffic directions of the train movement at the entry of the block section. It means this is the track, okay, this is the entry, okay, and maybe this is going to be your exit. Okay, so at the entry of the block section will be identified at each station for the train length measurement. So it means when the train is entering here, from here the calculation will start. The calculation will start. So we will know the train length. We will start calculating the train length when a train passes through the entry block section. Okay, the track circuit identified shall be such that all the train entering into the block section pass through these tracks. So whatever the train it is, for sure it should pass through this entry section. So from the entry section point of view, the train length measurement has been started. Okay, and the status of these track circuits shall be taken as input to the, so the inputs will be taken from here to the stationary unit. Okay, and the stationary unit will communicate the time offsets from the frame cycle reference to the BT occupied and also AT cleared, okay, to the concerned loco unit. It means they will tell, okay, if let us consider two tracks, one is AT and the other one is B track. Okay, so it will communicate, the stationary unit, the station unit will communicate to the loco, okay, will communicate to the loco unit, the train communication train collision avoidance system unit. The stationary unit is communicating, it will communicate to the train collision avoidance system unit of a loco that the B track is occupied, okay, and the A track has been cleared. So with the help of this, so which is being used by the loco unit for the precise location of the train length calculation. In case of overlapping territories, say for example, consider, okay, we have a signal, we have a signaling here, we also having a signaling here, it has a track. So if we have a overlapping, so this is the overlapping way, okay, this is the overlapping territory. If we have overlapping territory, the train measurement information shall be passed by the by taking over stations. So it means when from this station, okay, when it is passed through this overlapping point, from there we can able to calculate in case we have a overlapping territories. Okay, and also next most important thing is that the loco train collision avoidance system will determine the location, okay, of the train with the help of the RFID tags, data and the speed sensor output. And also loco train collision avoidance system unit will transmit the location to the stationary train collision avoidance unit every 2 seconds. Every 2 seconds the data from the train, okay, loco train will be, and it is sending it will send the information to the stationary train collision avoidance system. So the signal is being transmitted between these two peoples. So it means for every 2 seconds it will be in the full time supervision mode. Next, visual and audio warning. So visual and audio warning also we know. As long as the current speed is less than or equal to the permitted speed limit of the DMI, that is the display. Okay, that is the display we have inside the loco. Okay, in full supervision mode, the loco train collision avoidance system neither generate warning for brake application nor apply the brake. So if it is if the current speed is less than, okay, if the current speed, okay, is less than or equal to the permitted speed, so it is not going to create any sort of warning or a brake. But okay, when it is exceeding, okay, when it is exceeding, so when exceeding the speed, exceeding the permitted speed, what will happen? We need to create visual and audio warning about the expected brake intervention by the loco train collision avoidance unit being given to, it will be given to LP who is inside the station, that is loco pilot, to enable the loco pilot to react and avoid intervention. So visual and audio warnings will be provided provided to the loco pilot to enable the braking, okay, especially the braking intervention to avoid any sort of issues. Next most important thing is that supervision of the movement authorities and the speed limits. So the loco train collision avoidance system will supervise the end of movement authority. If this information is available on the board, then train shall be supervised for its static and dynamic speed profiles. If the train speed exceeds a speed by 2 km/h, warning of overspeed will be generated immediately. Okay, if consider situation, it should pass through at a speed of 100 km/h. If it is exceeding the speed from 100 to 102, immediately a warning of overspeed will be generated. And if the train exceeds, okay, the limit from 100 to 105 kilometer, example I am telling, okay, 105 km/h, the loco train collision avoidance system will execute the brake intervention along with the warning until the actual speed is not more than the permitted limit. So it means we have a brake intervention system which is already present inside the loco train collision avoidance system. Okay, and what are the salient features of this train collision avoidance system? As you can see here, it prevents spade. Okay, it means when the train is crossing through the danger limit, okay, it prevents that. Okay, when it is reaching near to the danger, immediately it prevents, okay, by automatic application of the brakes. That is the important advantage of this train collision avoidance system. In case loco pilot, in case loco LP fails to do so, this automatic application of the brakes will be done by this train collision avoidance system. It controls the speed within the specified limits. If 100 is the limit, it will not allow to exceed that limit either by 2 km/h or by 5 km. Say for example, if, as I told earlier in our previous discussion, if the loco is exceeding the limit of 100 km/h, example I am telling, okay, it may change in the real time. But only thing is that if it is exceeding 100 to 102 kilometer, immediately a warning will be created, and if it is exceeding 105 kilometer, immediately brakes will be applied. Okay. And most importantly, the most other important help of this train collision avoidance system is to reduce the probability of train collision in the block section, and also it indicates the movement of authority or display the signal aspects in the loco pilot cab. And also this cab signaling feature, which is very much useful for high speed trains during the foggy weather conditions. This cab signaling feature is very much useful, and also most importantly, it works on the principle of continuous update of movement authority. Okay, train collision avoidance system can be interfaced with existing interlocking, including relay based interlockings. Already this existing interlocking system is available. Okay, relay interlocking is available. We can interface this train collision avoidance system with that interlocking system, and also the loco pilot to follow the line side signals as per extend rule. Okay, and also this train collision avoidance system should follow the SIL, that is SIL, safety integrity level 4, as per SENELC or equivalent standards. Okay, and also this non-signaling based additional collision, that is head-on, rear end, side collision prevention features, and manual, okay, save or sold. Okay, all these non-signaling based additional collisions will be avoided with the help of this train collision avoidance system. And what are the different operational modes in the loco train collision avoidance system? We have more than 12 different operations: standby, staff responsible, limited supervision, full supervision, override, on-site, trip, post-trip, reverse, shunt, system failure, and isolation. These are the 12 different, okay, operational modes in the loco. Okay, next is the static speed profile. What is the static profile? It means it is a description of the fixed speed restriction for a part of a track sent from the track side to the train. So from the track side, signal will be sent to the loco. Okay, this is a track side. Okay, so track side signal will be sent to the loco train collision avoidance system. Okay, that is if there is any fixed speed restriction is happening, the signal often we will send and receive the signals often with the track as well as the loco. If it is exceeding the static speed profile, immediately some warning has to be created. Okay, so how we will know it? Say for example, your target is, okay, target distance is this, and this is your concerned speed. Okay, when you're exceeding the static speed profile, immediately for sure there is a possibility for this target to hit the danger point. Say for example, consider this is a station. Okay, here the train has to stop. Okay, consider the situation. Here we have another train and we have a signal here, signal over here. So what it should do based on the static speed profile, if the train is coming at a speed, for sure if it will cross through the target and there is a possibility for it to hit the danger point, immediately we need to send a signal back to the loco to control its speed. And in the same way, okay, we have a dynamic speed profile. So it is also a speed distance curve, okay, which a train follow without violating the static speed profile till the end of movement authority. So we have a starting point of movement authority, and also we will have an end of movement authority. Okay, so till the end of movement authority, the loco train collision avoidance system will follow the dynamic speed profiles. Okay, so as you can see here, this is a speed and this is a distance. As you can see, this is going to be a target distance. So in order to achieve the target distance, and say for example, if the train has to follow only the 80 kilometers per hour, say for example, if it is coming at 100 kilometers per hour, with the help of this dynamic speed profile input, it will control the speed to 80 kilometers per hour to reach the target safely. Okay. Next, what is this movement of authority? Movement of authority is a distance up to which the train is permitted to travel without the danger. That is the most important thing. If the train is exceeding this particular, if the train is permitted, say for example, we have considered we have a station of A, B and C. All these are small stations. Okay, consider we have a train coming from here, from station C. Okay, consider we have a train which should stop at train B, because that is the location, that is the movement authority which is being given to the train. If it is without causing any sort of damage, if the train is permitted to travel from C to B, that is the thing. If it is exceeding beyond it, it is a danger. And most importantly, with the help of the movement authority, the length of the movement authority is decided based on the signal approaching the stop signal. So when the train is approaching the stop signal, we will be able to identify the length of movement of the authority, and also we have a control chart to define the length of the movement of authority. And most importantly, in case of permissive signals, when the input for the signal indications are available, the ECR shall be used for the purpose of displaying the signal aspects. However, the movement authority will be based on the signal aspect of the approaching stop signal. Approaching stop signal is playing a vital role in determining the movement authorities. And also, in case when the signal indications are not available, the previous case the signal indications are available, in the second case we are considering we don't have any sort of signal indications, the signal aspect of the movement authority shall be derived based on the approaching stop signal. It means even if it is available, the ECR will be used for the purpose of displaying the signal aspects. Otherwise, if the signal indications are not available, immediately the signal aspect will be determined with the help of the stop signal. And most importantly, the movement authority for the last signal of the stationary train collision avoidance system shall be the physical distance between the last signal of the stationary train collision avoidance system and the foot of the next approaching stop signal. So it means most importantly, the movement authority will be specified in meters. It can be used for the train entering block section. And what are the subsystems of train collision avoidance system? Trackside equipments including the stationary train collision avoidance unit, onboard equipments which is present inside the loco, and also on the trackside subsystems. Inside the trackside subsystems we have RFID tags, we have a stationary train train collision avoidance system, we have a tower and the antenna which will be on the track side. So what will be on the onboard? In the onboard we have a loco train collision avoidance system vital computer, we have a RFID reader to read the tags which is present on the track side, and also we have a loco train collision avoidance radio unit, we have a driver machine interface, that is a HMI screen. In that one we can able to see everything. And most importantly, in the onboard subsystem, in order to control the speed, in order to stop the train with the help of braking systems, we have a brake interfacing unit. Whenever required, it will be used. So the same thing only we had explained here. The train collision system, we have two categories. One is the train side equipments and the other one is the onboard equipments, which is the loco train collision avoidance system equipments. On the track side, we have a RFID tag, stationary, and we have a tower and the antenna. Whereas in case of onboard equipments, we have RFID reader, we have a loco train collision avoidance vital computer, driver machine interface, braking interface unit, and most importantly the loco train collision avoidance radio unit. And inside this stationary train collision avoidance system, we have station train collision avoidance vital computer, we have a station train collision avoidance radio unit, we have a remote interface unit, and also we have station master operation cum indication panel. So this is how this train collision avoidance key components looks like. As you can see, this is the loco train collision avoidance system which will be inside the logo, and this is a loco pilot display, and this is the brake interface unit which will be present inside the loco, and this is the RFID reader which is going to read these tags. Which is going to read this RFID tags. And what will be in the station? Inside the station we have a station train control, station train collision avoidance system, we have a radio tower, we will also have a station master OCIP, and on the track side we will have these tags which will be fixed on the sleepers. Now since we have discussed about SMOCIP, which means a station master operation cum indication panel. So this is the panel which we are going to talking about. So in the station master's operation cum indication panel, we have indication for health. If it is healthy, it will be on the green. Okay, if it is unhealthy, this indication will be on the red. Okay, and also, okay, and most importantly, when the health will fail. Simple. When we receive some signal from the Loco train collision avoidance system as SOS, which means save our souls, which is a distress message. Okay, it will be generated. When this is generated, the soul SOS will be in the red. Okay, and also we have a LED indications for a common push button, and also we have a cancel push button, and we also have a SOS. So these three colors, or these three are most importantly the switches which will be operated by the station master, and most importantly, everybody cannot operate it unless and until if there is no station master key, nobody can operate it. So key is very much important. It means if you want to operate this station master operation cum indication panel, key is very much important. Okay, so this is how the Loco train collision avoidance system schematic looks. As you can see, this is the Loco. So we have a starting point, we have an ending point. So we have at the starting point we have a radio modem antenna for transmitting and receiving. We also have a GPS antenna for transmitting and receiving. We have a GPS inside the Loco. Okay, train, and also we have a Loco train collision avoidance system. We have a brake interface unit. We have a RFID antenna to scan the RFID tags which is on the track. So the same things which are present at the front side will also have the same thing on the back side of the Loco. So as you can see in the Loco or back side, we have a RFID to antenna. We have a Loco pilot. Okay, we have a Loco pilots. Operating interface panels. Two interfacing panels we have. We have a redundancy CAN bus, and also we have a radio modem and the GPS antennas. So this is how this the display of the driver machine DMI driver machine interface looks like. As you can see here, in this interface we can able to see what is the target, okay, what is the permitted speed, we can able to see the permitted speed, and what is the current speed, and what is the target distance, and what is the deceleration constant value, and what is the route indication, whether we have signals, proper signals, what is the movement authority, okay, and what is the mode which is presently it is working. All these things we can see in the driver machine interface. As you can see, this is some of the examples when the driver machine interface is running at the normal speed. This is how the display looks like, but when it is showing the over speed, so this is how it looks like. As you can see here, since it is at the limit, so it is showing it is good, but when it's exceeding the limit, okay, what is happening, it is showing red. Next we are going to discuss about the brake interface unit, which is going to play a very important role in case of emergency, or in case the Loco is exceeding the speed limits. So we have a train collision avoidance system. Inside it, in order to communicate with the locomotive brake controllers, we have two different things. We have electronic modules and the pneumatic panels. So this is a example of a radio communication arrangements of a absolute block system. As you can see here, inside the absolute block system, this is one station 1 and this is another station. As you can see, we have a train, we have a Loco, okay, we have a Loco in station 1, okay, and it is approaching from this station to this station. As you can see here, this radio frequency range is in this limit, and the radio frequency range of the second station is in the limit. It means there is a small gap, okay, they are not overlapping. This is the absolute block section. When the train is moving from here position towards this position, okay, with the help of these ranges, we can able to calculate the Loco is leaving the station 1, okay, at this speed, and this is the length of the Loco. And when it is comes in contact with the frequency range of the station 2, okay, the Loco train, when the Loco approaches the station 2, okay, immediately we will come to know that it is approaching the station 2. So this is how the absolute block section works, okay. So this is how you know, the signal transmissions of TDMA and FDMA schemes of a stationary train collision avoidance system. This is how it looks like, okay. And this is an example of multiple access TDMA and FDMA schemes. Okay, as you can see, so this is how the communication between the loco train collision avoidance system and the absolute block section works. As I told earlier, this is going to be a station 1 and this is your station 2, and this is their radio frequency ranges. When the radio frequency range of loco train is come in contact with the frequency range of station 1, they will come to know the loco is approaching the station. Okay, and in the same way, as you can see here, consider a situation, this is going to be a track 1 and a track 2. Consider a situation there occurs a collision already. Okay, there occurs an emergency situation already. Immediately what will happen, this is your station 1 and this is your station 2. In between the station 1 and 2 there occurs any sort of collision, even though it reaches, it comes in the frequency range of station 1, and it is being there for a long time, it means emergency scenario situation has been created. Immediately it will alert the other train which is already approaching the same station. Okay, and how this overlap zone of a automatic block section works, that is absolute block section. This is a automatic block section. As you can see here, we have a station A and we have a station B. Okay, station A, we have a station A and station B. As you can see here, the frequency ranges of station A and B is overlapping in between. So what will happen, even though if the train exceeding this, means at this point we will came to know it is moving from station A. Okay, the train is going to leave the station A. Okay, and there is a overlap region here. Okay, if any sort of issues or if it is being stopped here for a long time, some emergency situation will be created and will alert the other trains which is coming on the track. And in the same way, if the train reaches this frequency, we will came to a conclusion that train left to the station A and it reached, okay, and it reached station B. Those things we can able to came to a conclusion. How network management system connectivity diagram looks like. As you can see here, for each and every station we have different IP addresses. Okay, and also even for the network management system we have our own IP, and with the help of different Ethernet switches, okay, we will be communicating from the network management system to the different station train collision avoidance systems. So, and what is this downline? We will know. Downline here refers to the train traveling away from the headquarters. Means this is the headquarters. Okay, if a train moves from headquarters to the other location, it will be considered as a down. If it is approaching, okay, if it is approaching, if the train is moving towards, this is the headquarters. Okay, if the train is moving towards the headquarters, this is the other station. If it is moving towards, this will be considered as a up. Okay, so what are the different sort of information will the station control room will receive? We will receive, okay, what is the site name, what is from where it is getting down, okay, downline, okay, and it is going to approach which station, okay, what is the radio type we are receiving, and since through the GPS we will know the latitude and longitude information will be given through the GPS, okay, GSM antennas, and also we will know the power and the antenna gain and antenna heights also. Okay, most importantly, this will be the part of loco, and this will be on the station side. All this information the station control room will receive. Okay, and in the same way, okay, most importantly, we will also know the distance between the different sites. Okay, during the upline also we will receive the information from which station it is getting up, okay, from which station it is going to reach, what is the radio type, okay, and what is the latitude and longitude values, okay, and what is the antenna height on the field side, especially on the track side, and what is the antenna height on the of the loco. Okay, so all this information this station control room will receive, so that we can create a summary of the up time as well as the down time. So we will know, we will have a clarity of whether line is clear or not, is there any sort of obstructions, okay, and what is the receiving signal and what is the criteria range, whether the result is okay or not. All these things we can determine so that the station control room can come to conclusion with the help of this communication signals which is being transmitted between the Loco train collision avoidance system and the station train collision avoidance system. As you can see here, the cabling scheme. Okay, this is the first cable which we are going to lay down. This is going to be the power cable, okay, which will be laid from the IPS, okay, IPS room to that tower. As you can see here, we have a tower here. Okay, we have a tower here. So the cable will be laid from the IPS room to the tower. Okay, next OFC station to the tower. So we have a OFC. Okay, we have a OFC station here. From this OFC station, okay, most importantly from the OFC station, from the station train control train collision avoidance unit to most importantly the tower, okay, to the tower we have a cable. Most importantly we have a cable. This is going to be the cable for the radio modem. Okay, third thing, we are going to lay the cable from the station train collision avoidance systems to the office head. This cable is going to be the network management system cable. The third one is going to be the network management system cable. And next we are going to lay down a cable from station master room to, okay, especially the station master room to the operating panel, the interfacing panel which the station master is going to operate. It means the RS-485 communication cable. Okay, from the train collision avoidance subsystem track to the station master room we had pulled a cable. Okay, that is going to be your next cable. Next, from the OFC cable, okay, from the OFC, okay, the fifth is going to be the OFC cable from the station train collision avoidance system to RIU, that is remote interface unit. So as you can see here, we have a remote interface units inside it. Okay, next is we are going to lay down the cable, that is radio frequency cable. The sixth most important thing is the radio frequency cable, which will be laid down between the radio modems, okay, radio modems to the radio antenna. This is how the cabling activity will happen in the train collision avoidance system. So most important thing is that what are the different process design and documentation point of view in train collision avoidance system. First and foremost thing is that we need to create the wireless, okay, planning commission, licensing, independent safety accessories, verification, validation. Next we need to design the tower, okay, how the tower is going to be, what is the height of it, where we are going to locate the tower. Those things you need to decide. Next you need to prepare the floor plan in which you are going to install your train collision avoidance system on the track. And also most importantly, for the stationary train collision avoidance system, you need to have a numbering schemes. What is the tag you are going to follow, and you need to create the relay interface circuit, okay, and you need to create the RFID tag numberings, that is tin numberings, and also you need to create a layout. Okay, if this is on the track, what is the tin number 1, number 2, like that, those numberings you need to create. Okay, that layout also we need to create. And most importantly, what are the table of controls that we are going to take, okay, and what is this RFID tag data, and most importantly we need to set the station frequency. That is very much important. Either it can be a slot plan for FDMA and TDMA, and this is how the proposed plan looks like. As you can see here, this is the proposed tower location, okay, and this is going to be the water station, water tank, and these are the tracks, okay, this is going to be the up loop, and this is going to be the down loop, okay. So with the help of this RFID tag, okay, we have different types. One is the normal notation, another one is the signal foot, and the third one is the signal approach, and the fourth one is going to be the tin discrimination. We have a RFID tag at the gate, and also we have a RFID tag at the exit. It means with the help of a RFID tag itself, we can able to identify it is in the normal, or it is in the signal foot, or it is in the signal approach, or it is in the tin discrimination, or it is in the gate, or in the exit. And most importantly, we are also following the allotted codes for station train collision avoidance system for different railway zones. So maybe if we are coming under the southern railways, we have allocated code is 18 to 20. If you are going to be in a Konkan, it will be at 49. Like this, we have different codes, allotted codes for a stationary train collision avoidance system. See here, this is a simple example. As you can see here, this is how the RFID tags are getting installed, on the sleepers. So this is how it looks like on the track side. And most importantly, what is this power supply requirement to operate the loco train collision avoidance system? As you can see, if it is a diesel loco, the nominal voltage is 72 volt. And most importantly, the voltage limits will be in the range of 50 to 90 volt DC. And most importantly, if you are going for an electric loco, so the nominal voltage is 110 volt DC. So the limitations of voltage shall be in the range of 78 to 136 volt DC. And most importantly, what are the activities which will happen during the tower installation, tower related installation? So first and foremost thing is that first we need to decide the location. So before deciding the location, even though the location is decided, we have an area of railways to install the tower. First thing, we need to do the soil test from the reputed institute, whether the soil is capable of holding a biggest tower. What is the maximum depth we can do? Is there any rocks are available, or is there any possibility for earthquakes to occur? So that we will know when we test the soils. Second thing, we need to do the selection of foundation design. So soil, with the help of the soil test report, based on the soil bearing capacity, we need to put the foundation, and we need to test the foundation: sand test, cement test, cube test, metal test, bolt test, steel test, and TNT bar test. All these tests we need to do when we are doing the foundation. And also when we are doing the erection, we need to do the versatility test and galvanized check. Next, now foundation and the tower installation to be done in coordination with the civil engineer department. After erection activities, like after erection of a tower, once after doing all these tests in step by step, if we erected it, we need to do the other activities like tower painting, fencing for the tower, earthing, lightning arrestor, and aviation lamp indication. All these things we need to provide. We need to ground it properly. We need to provide the protection or fencing for it. Nobody, unauthorized personnel cannot access it. And also we will, after the tower is being erected, installed everything, after doing all these activities, we will do the installation of the radio modems, protocol converters based on the tower locations. All these things will be decided. So as you can see here, we have a station radio antenna, and this is the GPS antenna. This is the GPS antenna, and this is the loco radio antenna, which will be present on the loco train. And as you can see here, inside the tower, we have a radio modems. So this will be the power supply which is required to operate this radio modems. This is how it looks like. So next most important thing is that factory acceptance test. Even though you had got approved for each and everything, design, drawings, everything got approved, we need to do the FAT, that is factory acceptance test. So with the help of this factory acceptance test, what we will do, we will have a loco simulator in the PC. With the help of this loco simulator, we will generate the RTS, and we will also try to learn whether the loco train collision avoidance system is passing the signals to the radio modems properly or not. Those things we will check in the factory acceptance test. And in the same way, on the field side, with the help of this field side simulator in the PC, with the help of this, we will try to communicate with the relay interface simulator, and we will try to communicate with the station train collision avoidance system unit, and through the radio modems. This is going to be our display, and also we will also cross check the station master's OCIP as well. So it means we will try to know the factory acceptance test. All these tests we will do, okay, with the help of the Locos simulator and the field simulator panel. We will do this test. Next, what are the important configurable parameters? That is station time slot. Okay, it will decide the radio communication packets in the concerned time slot, and Loco time slot. It shall transmit the TX window slot to the Loco unit as a configured data. Station, that is save our souls. These things we will simulate with the help of the field simulator panel. We will simulate and check the train length, okay, whether when it is passing through AT and BT, whether we are getting the proper train length, and most importantly when it is entering the station and exit the station, whether the radio communication is proper or not. We will simulate the Loco position from the station entry point, and we will check. And next thing is that we will also, most importantly, the present and the next station ID. Say for example, if a train is moving from one station to other station, the ID will be different, okay. For the same train, when it is moving from that concerned station to the other station which we had from which it has came, the ID will be different. So those ID creations will be made, and most important, we will create the shunt limits, and also we will have the ahead signal aspects outside. So this is how the most importantly the layout design track. As you can see, we have a down loop, we have a down main, we have up main, we have a common loop, okay. We have a common loop, like this we have so many things. Next most important thing we are going to discuss about the anti-collision device network, that is RAKSH KAVACH. So it was a system which was being created by our Konkan Railway in 90 days. Okay, this anti-collision device system has been created with the help of the radio communication microprocessor and GPS technology. This anti-collision device system has been created. So using this system we can avoid the collision risk, and we can do the automatic braking action when there occurs any sort of emergency scenarios. So what are the unique feature of it? We can prevent the midsection, we can prevent the head-on collisions, we can prevent side collisions, we can prevent rear end collisions, like this. All these things we can use done using this. As you can see here, these are the two Locos, okay. We have a GPS receiver, we have a radio modems as well. As you can see, through the satellites we are communicating, we are sending and receiving back the signals, okay. So when it is working on onboard anti-collision devices, it receives input from the satellite, it will communicate with each other radio modems and use the intelligence to act to prevent the dangerous collisions, okay. And this why we are calling this ACD, anti-collision device network, as a RAKSH KAVACH. As you can see here, we can also call it as a train collision prevention system. As you can see here, we have a Loco anti-collision devices inside the Loco, and with the guard also we have a anti-collision device, okay. And as you can see here, we have a tower gate, okay. We have a radio tower, and we also have the unmanned anti-collision devices, GPS signals, okay, track side. So it means this is how the network of the anti-collision device networks looks like. So all these things plays a very important role. We have a station anti-collision devices, we have a railway stations. So all these things plays a very important role. They are going to be the network, part of the network, okay. So first and foremost function of this KAVACH is that we are detecting and preventing the head-on, rear end and side collision. This is the most important unique feature. And also we are detecting and generating the train parting or jumbling, okay. We are also creating the train approach warning for the road users at the level crossings, both manned and unmanned. We are providing the train approach warnings. and also we are providing the detection of falling and prevention of collision due to falling. And next most important thing is that we are also creating the station approach warnings to the LPs, that is loco pilots. Okay, so it will during the foggy weather conditions, okay, it is providing the 100% coverages to the ACD, that is anti-collision devices fitted trains, which is available to on the concerned routes. Okay, and most importantly we have a speed limit impositions, and most importantly we also have providing the provision of save or SOL, okay, manual SOS functionality, okay, which is available for drivers, guards and station masters to bring. So all these peoples have a authority, have a power to bring all the trains to halt within a radial of 3 kilometers in case of emergencies. So if it is in the radial distance of 3 kilometers, we can able to control and halt the train in case of emergencies. And we also have the automatic brake test, okay, so we will be generating the braking characteristic of the train with the manual feeding of data and of coach and as well as the loads. Next most important thing is that inside the network of onboard, as well as on the onboard will be on the locomotive side, that is loco side, and the track side, which will be this station, level crossing, loco shed, repeaters and the sensor based, all these will be on the track side. So this anti-collision devices works on the principle of distributed control system, DCS. Okay, this anti-collision devices which will interact with each other through the communication within the radial range of 3 kilometers. Okay, and most importantly this onboard computers use the input from the GPS system for determining the train location, speed, course of travel and time. And also mobile and stationary components on the anti-collision device network will exchange the information and take the decision based on the train working rules embedded in the software. If the two anti-collision devices are deemed to be at the risk of collision, this anti-collision system activates the automatic braking operation to prevent collision. If the loco anti-collision device is designed to interface with the various types of braking system of the locomotives. So what is this TID? That is track identification digit. It is a 2-digit decimal value which has a unique identifiers which will be on the track on which the loco as well as the guard anti-collision device is located inside the anti-collision device territory. Okay, we have different types. So if it is on the neutral side, we will have a TID neutral. If it is on the fail safe, it will be TID fail safe. If it is on the TID group, something different. If it is on the TID sliding, we have a different identification. If it is on the TID loco shed, we will have a different identification. If it is on the TID speed restrictions, it will be on the different, it will be represented a different way. As you can see here, this is how the station track identification digits, okay, track identification digit plan looks like. Okay, and this is how the prevention of head-on collision is avoided. As you can see here, we have a train 1 and train 2. We have two different IDs. If this is happening, with the help of this we can able to came to conclusion head-on collision is going to happen, so we can stop the train automatically. If there is a possibility, okay, of rear-end collision to happen, okay, we can avoid use with the help of this TIDs. And most importantly, if train is partly departed, okay, and derailed or infringed adjacent track, immediately we can do, if consider the train was in this track, immediately by changing the track from here to here, we are protecting the train. Okay, this is other prevention of side collision. Or sometimes if you know the train is out here, if you try to move here, there is a possibility for it to collide, so we will stop the train here itself. And also we will also plan the side-on collisions also. Consider it needs some space or distance. If it is going to hit here, so what we will do, we will change the track and we will move on to the other track. And most importantly, we can prevent the collisions at the level crossing. As you can see here, these are the level crossings. These are the lift barrier gates which we are going to use. As you can see here, if we have the manned level crossing, when it is open, so we will have a clarity of on which TID it is going, what is the hooter, how the train is approaching, what is the flasher value, all these things we can able to conclude. Next is the unmanned level crossing. As you can see here, when there is no man on the level crossing side. Even though there is no man, with the help of the photos, flashes and train approach warnings we can create to the peoples. Okay, so how we can implement this ACD network? First thing, we need to do the survey and route design. We need to manufacture and install the anti-collision devices and accessories. We need to do the commissioning of this ACD installation. We need to train the professionals, and we need to configure and do the customization of the ACD route during the incubation period. We need to commission the anti-collision device routes. We need to do the post-warranty annual maintenance if required. Okay. Next thing, we need to prepare the track ID platform and engineering signal plans. We need to list out the level crossings. We need to map the station boundaries. We need to create database of TAD plans and LCs. That is, LCs here refers to the level crossings. Okay. And this TAD survey on points, we need to do GPS and inter-ACD radio communication and GPS radio communication shadow lines. We need to create the database, and we need to finalize the requirement of the anti-collision device repeaters, and we need to make a detailed survey report, okay, including the cost of this ACDs. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. Since if the person who are listening to it, if you have any sort of clarities, and if you want any sort of upgradations, if you want to provide any sort of inputs on the discussed topic today, you can contact us, you can message us, you can provide your comments. Thank you so much.